natural terrain provides an excellent location for the shredder, with incoming waste entering by truck at the top elevation. Shredded product is removed by truck from the lower elevation. Incoming waste is handled by a 6-foot wide, 40-foot long, extra heavy-duty continuous piano hinge steel in-feed conveyor with variable speed drive. This is the Williams number 680 refuse shredder with its large opening feed hopper. To the right is a 900 RPM, 800 horsepower electric motor. Measuring 43 feet 6 inches in length, the live bottom receiving pit is large enough to accommodate bulky oversized waste and move it evenly into the shredder feed hopper. This shows the 800 horsepower drive motor. An International Model 100 skip loader moves waste from the asphalt unloading pad into the conveyorized pit. A special 1-yard, 4-in-1 type bucket better enables the skip loader to handle the wide variety of waste processed at Tacoma. Street pads on the loader prevent excess wear and tear on the asphalt receiving pad. Little or no sorting is possible at Tacoma. Therefore, feed to the shredder routinely includes demolition lumber, rubber tires, bedding and upholstery, including springs, and discarded appliances. Watch as waste is conveyed into the large opening feed hopper. Notice the absence of dust around the shredder. Sprays in the feed hopper introduce a small quantity of water, which suppresses dust and improves product density. Water sprays are automatically controlled, as will be shown later. At Tacoma, compression-type feeders were discarded as impractical because of the bulky, incompressible nature of the feed materials. The Williams shredder system has a capacity of 30 to 40 tons per hour of bulky waste material such as that shown here. Formerly, this incompressible material caused considerable trouble in the landfill, as it was extremely difficult to compact and therefore rapidly reduced the life of the landfill. Now the city of Tacoma utilizes this ground material as a top dressing or cover, and this operation will be shown at a later time. Williams advocates the use of extra heavy-duty feed conveyors to handle the abuse of year-round service such as this. Watch carefully as the loader pushes yard after yard of scrap lumber into the feed pit. Here we see a dramatic demonstration as the International skip loader tries to pack material down and into the feed conveyor. This type of abuse can occur with almost any type of loading system, and the in-feed conveyor must be built to withstand it. Beneath the shredder, a 7-foot by 8-foot twin drive oscillating feeder evenly distributes waste into the 30 cubic yard trucks. The product shown is ideal landfill top dressing. Different shredding grates in the 680 Williams shredder will produce considerably different product sizes as required. As the truck fills, the driver keeps track of the level and inches the truck forward as required to distribute the load evenly. Tests have shown that wood and OBW shredded to this size will have a bulk density of 11 to 15 pounds per cubic foot. Stoves, refrigerators, hot water heaters, and other discarded appliances frequently pose a serious problem to a landfill. At Tacoma, the Williams number 680 shredder will shred these materials without difficulty, producing a fist-sized steel product which will landfill easily. The heavy tank portion of water heaters can be handled as well as the steel refrigerator boxes. Here again, the large feed opening into the Williams shredder is all important in accepting these bulky articles without hampering the overall throughput of the system. While not within the scope of the Tacoma demonstration grant, shredded ferrous metal could be recovered for recycling by incorporating a drum magnetic separator downstream from the shredder. Previous experience with other shredder designs had pointed out problems which occur where metallics were shredded simultaneously with combustibles such as wood or upholstery. Metallics would be overworked due to extended residence time in the crushing chamber and leave the shredder at highly elevated temperatures. Hot metals frequently started fires when they contacted combustibles on the output conveyor. At Tacoma, no effort is made to segregate feed material. To do so would be impractical. Mattresses, wood, and rubber are shredded simultaneously with refrigerators and clothes dryers. In the Williams 680 shredder, the refuse is processed at such a high speed that residence time in the crushing chamber is held to a minimum. Thus, overworking and overheating of metallics does not occur. Another class of waste material which posed serious problems to current disposal technology is discarded bedding or upholstered furniture. Large mattresses with springs do not compact well in a landfill and cause voids. Because of their bulk, these articles can vastly reduce the load-carrying potential of trucks and shorten landfill useful life. Whether the solution to a given disposal problem will be landfill, transfer station, incineration, compacting, or high-density baling, sofas, mattresses, and the like must be reduced in size for economical, efficient processing. The massive shredder rotor revolves at 900 RPM, supported by two anti-friction bearings. Bearings are provided with a continuous supply of cool lubricant oil from insulated pipes connected to a pump and reservoir. The same oil system activates hydraulic access cover openers. Without disturbing the feed hopper, complete access to the shredder interior is available within minutes, as hydraulic cylinders swing the cover out of the way on hinges. A water-to-oil heat exchanger on the lube oil system is piped to permit spent cooling water to be reused as spray water in the shredder feed hopper. With the lever, the operator actuates the high-pressure hydraulic pump, which opens and closes the shredder access cover. A 20-yard Packer truck discharges 8 tons of refuse directly into the live bottom feed conveyor. The time required to process this 8 tons of refuse was recorded and can be translated to a shredder capacity in excess of 100 tons per hour. The wide open design and liberal clearances within the 680 shredder make high capacity possible without fear of motor overloading or plugging. Now let's watch as the motor load indicator on the Model E feed control panel shows the shredding power required. Shredding at a rate in excess of 100 tons per hour requires no more than 75% of the available 800 horsepower motor capacity. The shredded Packer truck refuse has been reduced to uniform size, ideal for landfill. Previous tests has shown that shredded Packer truck refuse will not support rodents, fire, or insects, and will compact to extremely high densities in the landfill, thereby doubling or tripling landfill life. This particular demonstration indicated an unbelievable product density of 22 pounds per cubic foot, based on loosely packed material falling from the shredder into the 30-yard truck.
Receiving material from the metering conveyor, coming through our belt system and dropping onto the first belt, which feeds the bimetal system. Material is dropping onto a vibrating feeder with the grizzly bar to remove large pieces which will plug the throat of the shredder. The material that's running through now is burned and has relatively low ductility and hardness and appears to be shredding very uniformly and very clean. We're running at the rate of approximately 4 tons an hour. The finished product is ending up after magnetic separation in an empty trailer. This is a representative mixture of the shredding operation with material pieces such as this, which are actually bypassing the shredder as per the design. As you can see from looking at this metal, there's a considerable quantity of heavy metal, which consists of rod, heavy wire, bar pieces such as this, small auto parts, and cans in between. This material is very clean and must have a density of at least 80 pounds per cubic foot.